In the pristine environment of a prototype, AI agents feel like magic. You submit a query, the APIs respond instantly, and perfectly structured data flows back without a single hitch. A single prompt seems to do it all. But expose that same agent to the messy, unpredictable data of a live enterprise environment, and the illusion shatters. By 2026, 88% of AI agent initiatives failed to transition from pilot to production, collapsing under the weight of edge cases and operational chaos. Here is exactly what that failure looks like. On the left, a simple programming while loop. On the right, the financial consequence. In 2025, a fintech company deployed an unguarded agent to reconcile transactions. It hit an error, entered a runaway loop, and burned $47,000 in API costs in just 11 days before anyone noticed. The core issue is single-shot prompting, asking the AI to execute a complex task in one massive command. It is like watching a chef blindly throw 100 raw ingredients into a single pot. The complexity overflows instantly. A single hallucinated word early in the generation process irreversibly corrupts all the reasoning that follows. A raw large language model is brilliant, but it is inherently chaotic. It operates like a master contractor showing up to a job site without a blueprint or a schedule. It requires rigid project management. To survive deployment, build the agent harness around the raw language model. First, the React loop locks in, forcing a continuous think, act, observe cycle. Next, a supervisor-worker hierarchy snaps into place. A single tech lead cleanly delegates to specialized workers, preventing unstructured data from multiplying errors. This exact organizational structure allowed Klarna to handle 2.3 million customer conversations a month. By enforcing a strict supervisor hierarchy, they reduced resolution times by 80% and generated $60 million in savings. Organizing this cognitive labor replaces the fragility of single-shot guessing with the stability of continuous lifecycle management. But an agent reading an endless stream of logs and conversation histories will eventually suffer from context rot. To prevent the model from drowning in its own memory, we use chat middleware. It acts as an invisible state manager, automatically summarizing and compressing old data to keep the reasoning sharp. Next, we must shield the system from outside attacks, like prompt injections. Watch as a malicious payload tries to hijack the AI. It strikes the functional middleware, a hard-coded checkpoint that inspects and rejects dangerous inputs at zero latency before the language model triggers. You also have to protect the system from itself. In one recent case, a compromised procurement agent was manipulated into bypassing human approvals, autonomously firing off $5 million in fraudulent purchase orders. To stop that, install a circuit breaker. Watch how this gate tracks incoming errors. When a failure threshold is hit, like an API timing out or hallucinating 3 times, the switch snaps open to halt the data flow and stop the financial bleed. If you catch a recursive loop, you apply the step protocol. It is a mandatory debugging methodology where you set strict iteration caps, trace the execution paths, ensure inputs mutate between cycles, and probe the exit conditions. Enterprise security moves past the hope that an AI will follow polite instructions. It anchors itself in hard-coded, deterministic software barriers. Even with strict safeguards, the final operational challenge is observability. Autonomous systems often fail silently. An agent might successfully trigger a tool and return perfectly formatted data, while the underlying logic it used to get there is entirely flawed. You can't debug that by reading raw text logs. You need a flight data recorder, which is why Arise Phoenix became the industry standard. This turns an opaque black box into a transparent glass box, revealing a precise tree graph that maps out the exact decision nodes your agent took. But if an agent operates continuously, reading vast code bases and execution logs over days, it hits the malloc-free problem. It allocates memory to ingest data, but it lacks the ability to selectively delete irrelevant tokens, leading to terminal context pollution. Developers solved this with the Ralph Wiggum loop. Instead of trying to manage an infinitely growing conversation history, they rely on a simple terminal bash loop to force a hard reset. Here is the mechanical execution. A fresh agent spawns, reads the updated codebase, pushes its work to a remote folder, and instantly turns to dust. A fresh agent icon immediately spawns in its place. Progress lives externally, immunizing the system against memory rot. Production-grade autonomy comes from engineering a perfectly constrained, disposable, and tightly harnessed machine.